Hi ladies and gentlemen, this is Miss Skokin. We're back in chapter 3, this time in section 3-5, slopes of lines. This is going to be a tiny bit of a throwback to what you learned in Algebra 1, so some of it is going to be familiar, but some of it is going to be new. Vocabulary, rise, run, and slope, and the essential question, how can we describe change using slope? As always, we have a warm-up to get us started, so I'm going to ask you to turn the video off, work on these questions, and turn the video back on when you're ready to check your answers. You can turn it off now. Okay, here is the work and the answers. Just a reminder that when we're talking about slope, it is much easier to deal with a fraction slope than it is a decimal value for slope, because we're going to be counting rise and run, and we'll see that in the next box. Also, a reminder on number 3 that we cannot ever divide by 0, so anytime we have a 0 in the denominator, that means that the value is undefined. In this case, m is undefined. All right, let's take a look at the box about slope of a line. And this says rise is the difference in two y values of 2 points on a line. If we have the graph in front of us, obviously we can count how many units it is. So here we've got 1, 2, 3, 4, 5, 6 units. And the other way that we can do that is we can find the difference between the units. So if we've got this y is 7 and this x is 1, we find the difference between those two numbers and we get the rise, 6. So two different ways. One is counting boxes. The other one is finding the difference between the two values. And we know then that this is the rise for our slope between our 2 points that are marked. Now, when we're looking at the run, that's the difference in the x values of the 2 points on a line. So here we can take a look at this. We've got a 5 and then we've got a 1. So the run is going to be 5 minus 1 or 4. The other way, of course, that we can do this is we can count boxes. If it's a small distance that we're looking at, 1, 2, 3, 4. If it's a large distance, the easier thing to do, of course, is to find the difference. But if it's a small difference, we can count the boxes directly on our graph. And you can see that what this did is it kind of created a little right triangle for us. Anyhow, the slope is going to be the ratio or the fraction of rise to run, meaning rise over run. And that means that we're finding the difference of the y's, putting that in the numerator, the difference of the x's, putting that in the denominator, and that's going to be our formula for slope. In example number 1, we're going to be finding the slope of 4 different lines, and I'd like for you, I know that you're able to do this very successfully on your own because of your training in Algebra 1, so I'm going to have you turn off the video, but I just want to give you a little bit of a reminder. I don't know if you ever met Slope Man, also called Mr. Slope Guy sometimes, and he gives us a bit of information. So we know that we can have slope going that direction, slope going that direction, and these indicate the positive and negative slopes that we might see. We also have vertical lines which have an undefined slope, and we have horizontal lines which have a slope of 0. So hopefully if you remember Mr. Slope Guy or Slope Man, that helps you when you recognize lines that are vertical and horizontal. For some reason those are the hardest ones to remember, but hopefully this will help you. Let's work through the first one together. To begin with, we need the coordinates for points A and B. So let's write those down. Next, let's write down the formula for slope. Now let's show proper substitution. And then, of course, we do the arithmetic. The result that we ended up with is that the slope is equal to 0. Looking at Mr. Slope Guy, we know that that must be a horizontal line. And in fact, when we look at line AB, we can see that it is, in fact, a horizontal line. Now, it's your turn to do the rest of them. Turn the video back on when you're ready to check all of your answers. Good luck. Hopefully you had good success with these the 3 questions that you did independently. I just want to remind you that when you're finding the slope between 2 points, it doesn't matter which point you designate as point 1 and which one you designate as point 2, as long as you are consistent in the numerator and the denominator. The other thing is we always need to simplify. So if you end up with something like -1 over -6, it needs to be simplified to 1 over 6. And once again, final reminder that it's much easier to deal with fraction slopes than it is decimal slopes. Okay, let's take a look at our box. We saw this on Mr. Slope Guy. The positive slope, as we read from left to right, read the graph from left to right, goes upward on the right-hand side. A negative slope, as we read the graph from left to right, goes downward on the right-hand side. A horizontal line has a slope of 0, so it is always going to be in the form y equals a constant. And a line with an undefined slope is always going to be a vertical line, and it's always going to be written in the form x equals a constant. One interpretation of slope is as a rate of change. For example, if y represents miles traveled and x represents time in hours, then the slope will give the rate of change in miles per hour. And we have a transportation example with example number 2. It says Justin is driving from home to his college dormitory. At 4 p.m., he's 260 miles away from home. At 7 p.m., he's 5 miles from home. We want to graph the line that represents Justin's distance from home at any given time. And then we want to find and interpret the slope of the line. So what we're going to have to do first, we see that we have a coordinate plane below. We need to scale and label our axes. In our explanation about slope as a rate of change, it said that x was going to represent time in hours, so that's going to be on our x-axis. It also said that y was going to represent miles traveled. In our example, because we want to draw Justin's distance away from home, we're going to make it distance away from home in miles. Once we've got labels, we want to scale. We're going to scale our time in hours by ones, starting with 1 hour, 2 hours, 3 hours, and so on until we get to 9 hours. In the vertical direction, we're going to scale by hundreds of miles distance from home. So we can count by 50s here. So we're going to start out 50, 100, and so on. Now that we've got our labels and scales, we're ready to graph our 2 points. The first one is going to be at 4 p.m. and 260 miles from home. The second one is at 7 p.m., 455 miles from home. Once we've got the 2 points graphed, we can graph the line that goes between them. Now we're ready to calculate slope. And we always start with our slope formula, and then do proper substitution into the formula. The last part of this question asks us to not only find the slope of the line, which we've done, m is equal to 65 over 1, but also to interpret the slope of the line. The way that we would interpret this is we would say, on average, Justin drove at 65 miles per hour from his home to his college dorm. We've now answered all parts of the question, and you can see that interpretation, the y over x, distance over time, does give us Justin's rate of speed. Okay, we're ready to move on to our next theorem. Slopes of parallel and perpendicular lines. In a coordinate plane, 2 non-vertical lines are parallel if and only if they have the same slope. And because vertical lines have an undefined slope, we have to specifically mention that any 2 vertical lines are also parallel to one another. In terms of perpendicular lines theorem, in a coordinate plane, 2 non-vertical lines are perpendicular if and only if the product of their slopes is -1. Vertical and horizontal lines are also perpendicular to one another. So vertical lines are perpendicular to horizontal, horizontal are perpendicular to vertical. Now, I know that when you took Algebra 1, the way that you looked at the slope, or perpendicular slopes, was that they're the negative reciprocals of one another. And this is the way we would show that in symbols, that slope m is perpendicular to a slope -1 over m, or the negative reciprocal. But if you notice, when we multiply those slopes together, if we multiply m and -1 over m, we end up with a product of -1 when we multiply them. So this is another way of looking at it. Perpendicular lines theorem tells us that we can multiply the two slopes together. If we get a -1, we know that they are perpendicular. If we don't get a -1 and they have the same slope, we know that they're parallel. Anything else, that means that they intersect but are not perpendicular to one another. Let's take a look at example 3, where we're going to be using these two new theorems that we just learned. Very often we're tempted to just look at a graph and say whether or not we think that lines are parallel, but we're not going to do that anymore. We're going to be specifically using the slopes. So example 3 says determining whether lines are parallel, perpendicular, or neither. We're going to graph each pair of lines and then use their slopes to determine whether they're parallel, perpendicular, or neither one of those two. In question A, we're going to first start out by graphing lines UV and XY using the coordinates that have been given to us. Point U is located at 0, 2, and point V is located at -1, 1. Once we've got those graphed, let's draw the line that goes between them. Next, we'll graph points X and Y with the coordinates that have been given to us. Again, once we've got our points graphed, we are going to draw the line that goes between them. Next, we're going to find the slope for both lines. Once we've found the two slopes for the two lines, what we're going to do is see what kind of relationship they have so that we can determine whether the lines are parallel, perpendicular, or neither. In this case, we see that if we multiply the slope of UV to the slope of line XY, what we're doing is we're multiplying 3 times -1/3, which results in -1. So that means we have proven that line XY is perpendicular to line UV. Okay. The next two examples, B and C, follow a very similar path, so I'm going to ask you to pause the video and work on question B right now. Turn the video back on when you're ready to check your final answer for question B. In question B, we find that lines GH and IJ are neither perpendicular nor are they parallel. When we get to question C, we are going to again graph the two lines and then calculate the slopes. Now, we don't have to graph the lines. We can just calculate the slopes and compare them. The reason that I think it's always a good idea to get a sketch at least of the two lines is so that we can check for reasonableness. Do the results of our slope calculations match what we see in the graph? It's a check for us, but it's not required. We can go straight to the slope and calculate the slopes to compare them. Once again, if we find slopes that are equal to each other, the lines are parallel. If when we multiply the slopes together, we end up with a product of -1, those slopes are parallel. I'm sorry, those lines are parallel. Let's go ahead and work on question C. And we'll start with graphing the lines. Once we've graphed the lines, and these do look like they could be parallel, but we're not going to make any assumptions until we go through the calculations, and that's what we're going to do next, calculate the slopes of both of these lines. We find that lines CD and EF are in fact parallel to one another because they have equal slopes. And the last thing that we see on this page is a caution, and it says, for given points, do not always determine two lines. And that's just a warning that sometimes we need to graph to make sure that the points are not collinear. We don't want to be tricked into finding an answer and again, not check for reasonableness. That is the end of this lesson, and now you are ready to work on your practice problems. Remember to show all of your thinking using your work. You can mark up the diagrams. In addition to marking up the diagrams, you want to find the slopes and again, show the work. If you have any questions, bring them to class. I believe you only have 9 questions to work on, so it should take you between 10 and 15 minutes. Good luck.